Yeah, welcome to this lesson. And in this lesson, we'll be treating the periodic table and periodic trends. So, first, I would begin with an introduction as to the periodic table. So, the periodic table is a systematic arrangement of elements in order of their increasing atomic number, and it provides a framework for understanding chemical behavior. So, when you see the periodic table, you would typically see stuff like this we have here on the right. So we have stuff like this where you have something that looks like this, having two columns on this side, 10 at the center, then 6 by the right. Then you also have some that's under that has around 14 columns. So let's go into the studies. Over time, the table has evolved into a powerful tool for predicting trends in elements properties such as the atomic size, the ionization energy, and also the electronegativity. Let's see the structure of the periodic table, what it actually looks like. So the modern periodic table is organized into periods and rows, where period is representing the um, horizontal rows, while groups are representing the vertical columns. So elements in the same group share similar properties. So this is just for knowledge purpose. Elements in the same group are known to share the same chemical properties due to them having same number of valence electron in the outermost shell. That's valence electron, meaning the electrons in the outermost shell. So periods show trends in atomic size and energy levels as we move from left to right. So periodic trends, let's observe some of these periodic trends. We'll be starting with atomic radius. Atomic radius decreases across a period due to the increase in nuclear charge. And this nuclear charge is talking about the charge that tries to pull species inside the nucleus. So the atomic radius of every atom seems to be decreasing down the group as we increase in atomic number. So meaning as we move from the left to the right of the periodic table, the size of atom would reduce in that same direction. So as you move from left to right, the atomic size would reduce. So, and the reason for this, as I said initially, is because of the increased nuclear charge. That is a force that's trying to pull in species. So, as the atomic number increases, it means that the positivity in the nucleus also would increase, and this positivity is going to pull species towards itself. So, and it will pull negative species towards itself. So, as it increases towards the right, as we move from left to right on the periodic table, the number of protons in the neutron increases. So this charge or this strength, this nuclear strength, increases also. So making it stronger and making it able to pull all those electrons that are revolving around the nucleus even more. So down the group, on the other hand, as we move down the group, the size is known to increase. The atomic size or atomic radius increases, and the reason for this is because of the additional shell that keeps on going as we move down um, each group. As we move down each group, the number of shells in each of the consecutive atoms tend to increase. So as you can see, we know lithium has just 2 shells, sodium has 3 shells, potassium has 4 shells. So that way, as you're moving downward, definitely the size would increase because the number of shells are increasing. So let's move on to the next trend. The next trend will be ionization energy. So ionization energy is basically the energy required to remove an electron from an atom. So the minimum energy required to move an electron from an atom is what is called the ionization energy. So what happens as we move across the period and down the group in the periodic table? So generally, as we move across a period, the ionization energy increases, and this is the same reason for the other instance where we're talking about the atomic size or atomic radius. So the same reason is why this one also increases, because as the nuclear strength begins to increase, it makes it difficult for you to be able to remove an electron in this case now. So to remove an electron will become difficult as we move down the group. That as we move from left to right or on the periodic table, it becomes more difficult to pull off an electron because the strength of the nucleus keeps on increasing from left to right. So on the other side of the description, down the group, it also decreases, similar to atomic radius. And the reason for the decrease is because of the increased distance from the nucleus. So as the shell begin to increase, the shells are surrounding the nucleus. You put the first shell, put the second shell, put the third shell. They are making the electrons becoming farther away from the nucleus. So, and due to this distance from the nucleus, it becomes easier to take off something from the nucleus. Just as though if you were trying to, maybe let's say a shepherd has like 5 sheep, it would be difficult for him to for something to just come and take off from his 5 sheep. But when this shepherd has like 100 sheep, or the sheep begin to expand farther away from him, it becomes easier for you to steal off sheep his sheep. So that's the same idea that is happening or coming into play in this instance. So let's move on to the next trend, the electronegativity. So electronegativity refers to the ability for an atom to be able to attract electrons to itself in a chemical bond. So in a chemical bond, we have two atoms, whether the same atom or different atoms. So we have two atoms that would always make up a chemical bond. So the inherent ability for a particular atom to be able to pull electron towards itself in that bond, specifically in that bond, is its electronegativity. So, and as we move from left to right, that's across a period on the periodic table, the electronegativity seems to increase. The electronegativity begins to increase because species, their number of electrons increase more, and also the nuclear strength also increases more. So the nucleus will be able to pull in more, because since the nucleus is becoming strong, it will be able to pull in its own electron and any other electron that is close to it. So the bonds that probably are forming is bonding an atom with another atom. So let's assume you have probably atom A and atom B, and atom B has a stronger nuclear charge. Atom B would draw its own electron towards itself, and also any electron of any species that is bonded close to it, it will pull those one's electron towards itself also. So in that way, it will now make the atom B have stronger pull, like a higher electronegativity. So if we were to now look at these species in the periodic table, we're not trying to say any element that will be taking the position of atom B will be towards the right hand side of the periodic table, because elements towards the right hand side of the periodic table are those ones that are stronger. So meaning when you are looking at bonding two elements, if you want to know which one will be more electronegative, you check the periodic table where it falls on the periodic table. If it falls on the right hand side, it means, and the other element that is bonded to falls on the left hand side, it means the one on the right hand side will be more electronegative than the one on the left hand side. So that's just the idea behind this. So when you go down the group, the same thing happens. As you go down the group, distance become farther from the nucleus, so the nuclear strength begin to reduce. So the same idea flows in the case of electronegativity. So let's move on to electron affinity, the next trend. So electron affinity is talking about the energy change that occurs when an atom gains an electron. So take into account the word energy change. So it is the energy change that occurs when an atom gains an electron. So it becomes more negative across a period. So when an atom gains an electron, it means initially, as it was neutrally charged, and it accepting extra electron, it is becoming more negative. So the energy change that would happen is that it will be indicating a stronger tendency for you to accept electron. It's been getting a stronger tendency for you to accept more electron. So as this occurs, this particular energy change that happens when an atom accepts more electron is what is called the electron affinity. So across the period, it is known to become stronger, and the same reason, the same thing that is applying, because as you move down each period, it's always known that the tendency to pull electron is becoming stronger. So down each group, the electron affinity becomes less negative. So down each group, the electron affinity becomes less negative, because it becomes the energy that is required to pull an electron becomes like stronger. You need more energy to pull an electron from that distance. So on the lower side, let me start from the across the period again. So when you go up across the period, the species at the end, the energy change that they would need, that is the initial energy and the energy that they would lose when they try pulling an electron, it will not be really significant because they already have the strength. So while the ones that are down, that are going down the group, the energy, normally before they would even be able to pull an electron, they will need high energy. So that's why they said the electron affinity becomes less negative, meaning it will become more positive. That is, the change in energy will become more, because they will need more energy to be consumed when they're trying to pull an electron towards themselves. So now let's go on to conclusion slide. The periodic table is an essential reference in chemistry, so revealing a predictable pattern, which is known as the periodic trend. So understanding these trends of atomic size, ionization energy, electronegativity, and also electron affinity would help chemists predict behaviors and reactivities of elements. So this idea, I think it's one of the fundamental ideas that every student of chemistry or any chemist should have, because going on into chemistry, it would help you to build deeper understanding of some other concepts as we move on. So that will be the end of this lesson.